initially the capacitor of the capacitance is initially uncharged, and in order to charge the capacitor, you have to close the switch to point A. So the switch is here, and you have to move it to point A. And by doing so, you charge the capacitor. So now you have the EMF device, which is the battery, and the current flows through the switch, through the resistor, and through the capacitance, which makes it an RC circuit. And so, so when you're doing that, you have the total volt equals the voltage on the capacitance plus the voltage on the resistance. So you have the voltage total is going to be the EMF because that's where the voltage source comes from. So you have EMF equals, so for the voltage on the capacitance, going from last year, we learned the formula Q equals VC, and solving for V, you get Q over C equals V. So the voltage on the capacitance is Q over C, and the formula for voltage for resistance is V equals IR. And since the current is going this way, and then this way, you see it's going down, so the current's going to be negative. And so you have IR. So in order to get to simplify the I, we go back to a formula we learned from last chapter, dq over dt. So we replace I with dq over dt times R. And we want to make dq over dt alone. So we multiply the whole thing by 1 over R, and we get E over R equals Q over RC plus dq dt. And then from there, we can simplify this by moving Q over RC to the other side to make dq over dt alone. So you have E over R minus Q over RC equals dq over dt. And in order to simplify this, we can multiply each side by C. So you have CE minus Q over RC equals dq over dt. And so we want to get the Q's together. So you have dq over CE minus Q equals dt over RC. So we're going to integrate this, and so this is a du over u, and the derivative of negative q is negative dq, so we put a negative sign here and a negative outside. And so, and also the bounds is, for the left side, we want it from 0 to some q, and we want the right side from 0 to some t. And so when we do that, we get ln, negative ln of CE minus q with the bounds q and 0 equals T over RC from T to 0. We also know that RC is a constant because it's not changing. So we have negative ln C E minus Q plus C E. Just to make everything neater, I would multiply this by -1. So you have ln C E minus Q plus minus ln C E equals negative T over RC. From there, you can simplify this even further using the natural log rules. So you have ln C E minus Q over C E equals negative T over C. And you can simplify this even further down to 1 minus Q over C E equals negative T. Now, we want to get the Q alone, so we raise each side to the E power. So we get 1 minus Q over C E on the left-hand side, and on the right-hand side we get E to the negative T over RC. And we bring it over, and we get Q over C E equals 1 minus E to the negative T over RC. And then we finally get, by multiplying CE to the right-hand side, we get Q equals CE 1 minus E to the negative T over RC. Now the CE represents your max charge on the capacitor, and you can see as time increases, Q is going to level out and it will reach a maximum point, which is going to be your CE value.